In every example, the statements are treated as true for the sake of evaluating their logical relationships. Logic does not ask whether the statements are factually accurate. Instead, it examines whether the conclusion follows from them. For instance, look at set 5. Harry Potter is a wizard. All wizards can perform magic. Therefore, Harry Potter can perform magic. Here, logic does not concern itself with whether Harry Potter exists or whether wizards are real. It simply evaluates whether the conclusion follows from the premises. In this case, it does. However, consider this variation in set 6. Harry Potter is a wizard. All wizards can perform magic. Therefore, Harry Potter cannot perform magic. This conclusion is logically invalid because it contradicts what would follow if the premises were true. Not every consistent collection of premises yields a conclusion. A valid conclusion must necessarily follow from what has been assumed true. If we continue to set 7. Unicorns are mammals. All mammals can fly. Therefore, unicorns can fly. This argument is logically valid. If the premises were true, the conclusion would have to be true as well. Of course, the premises are false. Unicorns don't exist, and mammals generally can't fly. But that doesn't matter for logical validity. Logic only asks whether the conclusion follows from the premises, not whether the premises are actually true. Lastly, we can focus on set 8. Cats are animals. Dogs are animals. Therefore, cats are dogs. Here, the premises are actually true, but the argument is logically invalid. The conclusion does not follow from the premises. Just because two things share a property, being animals, it doesn't mean they are the same thing.